Applications of resistors. Current control. Resistors may be used to adjust or limit the current in a circuit, for example, volume control. So in our circuit, we've got a 12-volt power supply. We've got a decade-resistant box acting as a variable resistor. We've got two 1.5 kilo-ohm resistors in series, so they're acting like the 3 kilo-ohm load resistor. And we've also got an ammeter to measure our current. We are wanting to calculate the maximum and minimum currents through the load resistor. So to do this, we know that current is calculated by the voltage divided by the resistance. So for a fixed voltage, the maximum current is whenever the resistance is minimum, and the minimum current is when resistance is maximum. So our minimum resistance will be when this is set to 0, so we'll only have the 3 kilo-ohm resistor in play. So our minimum resistance is 3 kilo-ohms. Our maximum resistance is when this is set to 2 kilo-ohms. So we have 2 kilo-ohms plus 3 kilo-ohms. So our maximum resistance is 5 kilo-ohms. So we can calculate our maximum current as the voltage divided by the minimum resistance. So 12 volts divided by 3000 ohms, and that gives us 4 milliamps. The minimum current is 12 volts divided by the maximum resistance. So 12 volts divided by 5,000, and that equals 2.4 milliamps. But we can turn our circuit on to measure, to see if we're right. So this is with our minimum resistance, as this is set to 0. So we've got a current of around 4.4 milliamps. And if we set it to 2000 ohms, so that we have the maximum resistance, our current is around 2.6 milliamps. Now, our measured results are larger than our calculated results, and this will probably be because the voltage is larger than stated on the power pack. So the voltage is probably larger than 12 volts. So we can measure this to find out. So the voltage is around 13.2 volts. You could use this voltage of 13.2 volts along with our maximum and minimum resistance figures to calculate whether our recorded values are correct.